Clustering of text documents using K-means algorithm. Actually, clustering is one of the techniques of data mining. Data mining means extracting knowledge from large amount of information. Clustering is the process of organizing similar objects into groups called clusters. In other words, a cluster is a collection of similar objects. Clustering of text documents is an important step in information retrieval, management, and mining of abundant text data on the web or in corporate information systems. Basically, there are two types of clustering. They are partitioning clustering and hierarchical clustering. In partitioning clustering, we need to specify the number of clusters initially. This partitioning clustering can be implemented by two algorithms, K-means and K-middle. Whereas in hierarchical clustering, there is no need to specify the number of clusters initially. Hierarchical clustering is of two types, agglomerative hierarchical clustering and divisive hierarchical clustering. Agglomerative hierarchical clustering follows bottom-up approach for document clustering, whereas divisive hierarchical clustering follows top-down approach for document clustering. We have implemented K-means algorithm as our main project. The input for the K-means algorithm is the number of clusters, that is K, and a dataset containing n objects. The output will be a set of K clusters. There are 5 steps in our algorithm. The first step is arbitrarily choose K objects as initial cluster sectors. Repeat, assign each object to the cluster to which the object is most similar. Update the clusters until no change. Steps in our algorithm. Initially, we have selected a dataset containing 800 objects. Here, objects are nothing but documents. Then we have identified all the unique words from all 800 documents. Now, after identifying unique words, we have generated input vectors. Input vectors in our K-means algorithm are 4 kinds. They are Boolean vector, frequency vector, TF-IDF vector, and reweighted TF-IDF vector. Now, after generating input vectors, we have generated similarity matrix using one of the following similarity measures. In our K-means algorithm, there are 6 similarity measures: cosine, Jacquard, Dice coefficient, simple matching coefficient, Pearson correlation coefficient, and average Kullback-Leibler divergence. Using any one of the similarity measures, we have generated a similarity matrix for the document. Then we need to specify the value of K, that is the number of clusters. After specifying the value of K, randomly select K documents and place one of K selected documents in each cluster. Place the remaining documents in the clusters based on similarity between documents and the documents present in the clusters. Compute centroid for each of K clusters. Again, by using similarity measures, find the similarity between centroids and input documents, that is, generate similarity vector. Now, place the documents in the clusters based on similarity between documents and the centroids of clusters. After placing all the documents in the clusters, compare the previous iteration clusters with current iteration clusters. If all clusters contain same documents in previous and current iteration, then terminate the algorithm here and we will be obtaining the final clusters. Else, repeat through step 7. We have implemented entire K-means code in Java. The input for our code is a dataset consisting of 800 documents belonging to 4 categories. The 4 categories are CAG, SIS, CRA, and MET. There are 200 documents for each category, and hence we have 800 documents in the entire dataset. The entire code for K-means algorithm is placed in K-means folder. Just open the folder, go to kmeans.bat and double click it. The moment you double click kmeans.bat, command prompt will be opened where the code will be compiled and executed. Now, in the GUI, hit the browse button in order to select dataset as input for our algorithm. Then select any one of the input methods, that is either frequency count or TF-IDF or reweighted TF-IDF. Let us select TF-IDF as our input method. We need to select any one of the 6 similarity measures. Let us select Pearson correlation coefficient as our similarity measure. Now we need to specify number of clusters. Since we have taken a dataset consisting of documents belonging to 4 categories, we will specify number of clusters as 4. Now press the button run. The moment you press the button run, final output in the folder named clusters, which is present in KMeans folder. Just open clusters folder. Here are the 4 final clusters obtained as a result of previous execution. Cluster 1 consists of total 198 documents, of which 194 belongs to mid category. Cluster 2 consists of total of 198 documents, of which 192 belongs to TRA category. Similarly, cluster 3 consists of total of 169 documents, of which 163 belongs to CIS category. Likewise, cluster 4 consists of a total of 235 documents, of which 191 belongs to CAC category. Now, we will find the accuracy of clustering. As I have already shown that in cluster 1 have 194 documents belonging to MED category. In cluster 2 we have 192 documents belonging to TRA category. In cluster 3 we have 163 documents belonging to CIS category. And in cluster 4 we have 191 documents belonging to CAC category. We need to perform sum of these 4 values, that is 194 plus 192 plus 163 plus 191, which is equal to 740. Now divide the sum by total number of input documents, that is 800, and now multiply the resultant with 100. Here in this particular execution we will be obtaining a value of 92.5. Thus, the accuracy of clustering is 92.5%. Similarly, run the code for different input methods and appropriate similarity measures in order to obtain the clusters. After obtaining clusters, find the accuracy of clustering as shown here. Thank you.